Next speaker is Kornél Kovács. Kornél Kovács is an experienced development manager with multiple product and managerial roles in his past. As VP of Delivery, he is leading the full development at Transcend and focuses on people-centric leadership and result-oriented mindset. The title of his talk is The IT Path to Universal Measurement. Please welcome on the stage with a huge round of applause, Kornél Kovács.
Welcome. Welcome, ladies and gentlemen. I would like to get a confirmation that you can hear me right. It's perfect, it's working. So hey all, I am Kornél Kovács. Currently, I am the VP Delivery at Transcend. And I would say that that's more than enough from my side. About me, I am a very boring person, so I would just jump into my presentation. So we, at Transcend, we are working in the critical infrastructure industry, automating and designing wastewater treatment, electrical substations, and many other things. I bet this didn't tell you a lot about what we are doing in practice, and don't get me wrong, but I won't specify the smaller nuances about our company. I wanted to have a topic that can teach something to us, and at the same time, it can give a little bit of spotlight for why being in the software industry can truly change your life, if you are open for the challenges. And you are not just a person who is trying to survive just another day at the office. At the same time, I hope I can give you a feeling why it's good to work here, how Transcend challenge or problem does look like, how we solved it, and why it makes sense to be a little bit of lazy in a good way if you would like to be a good software developer or manager. I know. I can already hear you. VP of Delivery at Transcend says it's good to be lazy at your workplace, but it's not about that. But if you don't want to save time, skip unnecessary steps that you could automate, then yes, maybe you are not lazy, but you are not that smart as well. We need that healthy laziness to create the motivation to save time. And I know it can be complicated, but usually fun times at our workplace are not coming when we are doing the boring and straightforward tasks. Those are coming when we have to jump outside of the comfort zone, when you have to think about what is happening out of the box, when you have to face with complicated challenges and truly use your brain. But I know, complicated, yes, complicated can be complicated. But before we would jump into the complicated part, I already told you that we are working in the critical infrastructure industry. With more detail, we are creating a software called Transcend Design Generator, aka TDG, which is automating the creation of engineering documentations. A lot of process, mechanical, civil, and substation engineering are happening at Transcend. But I didn't want it to just have a topic that needs those huge understandings on those specific fields. I wanted to bring here something that has a lot of connection with real-life examples, that has connection with a huge headache to us, what happened in the past. It has a connection with some minor physics or science, or maybe a little bit more than that, we will see it later, but it has a lot of connection with all of you. Actually, it has a lot more connection with all of you than you would originally think. So my presentation today focuses on a rarely used science, metrology. Not that one. That's a different kind of animal, not meteorology, just simply metrology. But what is metrology? And why it was a problem to Transcend? So metrology is the science of measurements and how to use them properly. Probably this is the most frequently used, yet not really known field of science. Since who doesn't want to get the deciliter of milk for a coffee or drives 50 kilometers per hour with a car? But don't be afraid, we won't jump into the deep science part of it. But we will see how we can use this or other rarely used scientific concepts and combine them with our general laziness of software development to solve problems and issues easily that seemed much more complex. So what are units? It seems like a very easy question. Everybody learned it early on. It's very basic. As in the company, we used to say, unit is something that can be derived from an SI base unit with only having magnitude differences. So let's look at an example. Meter is a unit, and kilometer is a unit, because there is only a magnitude difference, aka I can easily convert them with only multiplying or dividing. Inch and feet are also units, because with the same principles, I can easily just convert them with only multiplying or dividing. But if we are looking at it from the specific terminology, then neither Celsius nor Fahrenheit are units of temperature. Only Kelvin is, because Fahrenheit and Celsius has difference between the origo of the units. Obviously, this is just simplification, and many different kind of fields has its own way of thinking, how they are measuring something special. But those are not really units in the sense we talked before, but bits of measurement for something special. There are tons of examples, starting from brake horsepower, which is the unit of car enthusiasts are measuring the output of their engine, which is not really comparable with any other power metric, since it has calculation to the loss of friction and with other things. On the wastewater field, we have many of these, but the best way to easily describe them is probably the most common one. A common one you don't even realize. How tall is the Mount Everest? According to Wikipedia, it's 8,848 meters. But technically speaking, this is also not a real unit, because it is not just meter, but meter from the sea level. So there is an outside correspondence which makes it very difficult to compare with something like Olympus Mons on Mars, but there is no sea level. But after this, now let's talk about the official units. And here comes a little bit of science part, and also I know that it would be really difficult to get answers at this forum, so I will ask a question, you don't have to answer it. I am completely satisfied if you are just thinking about it, but still I'm going to ask a question. So do you know how many SI base units do we have? SI is the global standard for scientific measurements. This is the part when I am waiting, while you are thinking about it. I can see it in your eyes. Yeah, 11, 12, yeah, it's 7. Almost. Can we name them? Do we know them? It's a very silly question. We just counted it. Of course we can. So the first one will be length, with the base units of meter. And it's very straightforward. We are measuring length with it. Yes. The second one is time, with the base unit of secundum. It's a very good example for non-decimal conversions. We have mass, with the base unit of not gram. Usually a lot of people think that it's gram, but actually kilogram is the official one. We have temperature, we just discussed it a few seconds ago, with the base units of Kelvin. We have the electric current, with the base units of ampere. We have the amount of substance, I hated it at school, with the base units of mole. And last but not least, we have the luminous intensity with the base units of candela. So we have all these 7. And the trick is, every other metric, every other unit what we need, we can write them down and we can put them together with only using this. And if you don't know this will basically blow your mind. But technically speaking, every other unit is just derived from these. But now I will show you 3 examples. The first one will be a very easy one. It's called velocity. So velocity is basically distance divided by time. But as you can see, we only use SI base units for the calculation. The second one will be almost the same. It will be acceleration, which is length or distance divided by time again. No magic yet, just use SI-based units for the calculation. But to see a little bit more complicated one, we can look at it to the electric voltage. So voltage is basically mass multiplied by length squared divided by time on the cube and also divided by the electric current. It's very rare to use all 7 to describe a unit. Usually the complex metrics and units can be described with only 4 or less. But actually, if you are very specific with something and you would like to see very complicated calculations, there is a situation when actually you can use all 7, but usually that's not the case. A couple of years ago, we at Transcend, we faced with an issue. It was a huge problem to us. Meaning we had to use different kind of units for imperial and metric preferred clients. And we have to use many other ones based on specifications. On the wastewater field, the most frequently used unit what we have is called the volumetric flow, which is not a very frequent one in a general person's life, but this explains how much of something flows in or flows out in a designated time frame. We are working in engineering automation with electrical substations, wastewater treatment plants, and drinking water plants. And if you go out from this building, actually you can find somewhere a water tower here. I found it already, but you can find it. It is something that we officially call an elevated finished water storage. So that water tower can provide 500 cubic meters of water to the neighboring area every day. This is the volumetric flow, 500 cubic meters per day. In this field, for this specific thing, we have many different kind of units. Most likely, we use cubic meters per day or cubic meters per hour, but the other side of the ocean, we have GPD and MGD, which are gallons per day and million gallons per day. But others are using CFM, aka cubic feet per minute. If we are looking at it from a development point of view, obviously there are some great libraries out there which are basically transforming these units and simply converting them. But what we needed was something that we can count on, or should I say count with. And if you look at it from a developer perspective, let's get a simple calculation. If you have length and you divide it by time, you will get the velocity. It's a very straightforward one. You can just code it with an operator. If you have length and you divide it by time, it will create you the velocity. But what if the calculation is not that simple? What if you have to happen a large variety of calculations to happen? That might not be that straightforward, but at the end, still you will get your result in a common metric. When we created our tool, measurement units or M units, our goal was to create something as a universal remote control for unit conversions within our engineering projects. This dynamic tool helps us to manage and convert units even when they are not commonly understandable, even when they are not real metrics, just technical units. But what do I mean by that? Not real, just technical units. The easiest way is probably to look at an example, and we will use the generic distance, acceleration, time equation that you can see here, which stands for length equals acceleration divided by 2 multiplied with time again. Not a really complicated calculation at all. But depending on the language you use and how it orders things, you can have some problems if you are using a generic unit library. But now let's look at it, how would you code it? And for the sake of simplicity, I just won't divide acceleration with 2 because it has nothing to do with the unit. Dividing acceleration with 2 won't change the unit, but currently we are only interested in the unit. So we have length equals acceleration multiplied with time again. And if you look at it, the first part makes sense. You have acceleration, you will multiply it with time, it will create the velocity. multiplied with time again will create the distance. Easy deal. But what if I would change up the order and I would bring the times at the start? Then we would have to multiply time with time, and that is not generally not generally something that has a name. So first you have to invent a name for it. Then after it you have to handle all sorts of usages where it can happen in an equation. But what we have is rarely that simple. A prime example for M units in use is our blower sizing calculation, for which the equation you can see here. So we have integrated M units to our sizing.tools website, which we created for more accessible blower and pump sizing for engineers. But the main thing about M units, the fact that it is not relying on us to know the exact metrics or units, because sometimes there is none. But now after this, how can we use these bits of scientific knowledge to generalize a problem that seems very complex? This is the situation, this is the thing when we are translating our knowledge into the thing we call measurement matrix. Although this is just a vector, but a vector is a matrix too, with just one dimension, so we will stick with the name. So now let's look at every metric on the multiplications of the powers of the base matrix. I will repeat this because it's very important in this level. Let's look at every metric as the multiplications on the powers of the base matrix. What do I mean by that? Now let's create several little numbers. Each one will represent the power on each base metric is. So the first one will be length. It will be a very straightforward one. It will be a simple one at the start and 6 zeros. Every other base unit will be similar, but how would velocity look like? It will be 1 on length and minus 1 on time. And if you remember from math class, minus powers means reciprocals. So in this context, it will mean 1 divided by secondum. We can show acceleration too, it's almost the same. We have 1 on length and minus 2 on time. But to see the complex one, what we already discussed before, let's see the electric voltage, which is basically 2 on length, minus 3 on time, 1 on mass, and minus 1 on the electric current. So basically, what does this mean? When next time you will have a conversation with your friends about electric voltage or volt, then you can just flex a little bit because, you can say that, yeah, guys, yeah, volt, but also known as this. I won't spell it out. But basically, this is volt. So after this, how does this help us? Why is this good? From this point, we unlock the capability to utilize any kind of units or metrics, even without knowing their name, or even if there is any. Take as an example the Planck constant, which is not very well known outside of scientific circles, but it's very, very important in quantum mechanics, forming a bedrock of technologies such as LED, solar cells, quantum computing. All of those technologies are relying on the principles of how energy and matter interact on the smaller scales. But this has no official unit name. None. But I have the measurement matrix we explained before, and I can easily name them. I can easily understand them, even without knowing the name of it. But this is just the beginning. If these are vectors, then what I can do with them are basic vector operations. This is just a reminder, we already explained this before. We have length, we have time, we have velocity and acceleration. These are just the vectors of them. Don't get me wrong, we just called it matrix, but these are the vectors. Why would I do that? Why would I do basic vector operations? Why? I'm going to show you 2 examples for this one. The equation is very familiar to you already. I won't explain it again. Just a simplified version. So length equals acceleration multiplied with time and multiplied with time again. And as you can see here, here are listed the vectors of these units. And if we have multiplication in an equation, the only thing what I have to do to identify what will be the unit of the result is just to basically I have to add the vectors together. And as you can see at the end, we just got the vector of length. But if there is a multiplication, there is a division as well. So I'm going to show an example about it too. The difference between multiplication and division is very simple. In the case of division, we just have to subtract the vectors from each other. And as you can see, we just got the vector of velocity at the end. Sorry. OK, now we solved our issues with the complex calculations. But how does this help us with our original unit conversion issue? So now, just for a minute, let me tie back to the original unit conversion issue what we had at the start. At this point, we already learned that every kind of unit can be written down with only base units, SI base units. Now we put every kind of non-base matrix into the measurement matrix we explained before. The last thing what is important to me to do the necessary conversions is to know the differences between the base and the non-base matrix. So transforming from cubic meters per day to cubic feet per hour is just simply the difference between feet and meter on the third divided by the difference between day and hour. But you don't have to know every level of matrix. Still, there are situations when we have to add non-base matrix into the matrix like we added gallon for volume. But you only need to add it once. And from that exact point, it will be there for you in any kind of equation that you would like to use it. But you only need to name it once. In wrapping up, let's make one thing very clear. Metrology isn't just a niche corner of science. It's a cornerstone, both in engineering and development. It's essential, and here is why. Understanding and using units effectively is like having a Swiss Army knife in our toolkit. Whether we are tweaking a wastewater system or just working on the next big software update, the principles of metrology apply across the board. Here at Transcend, we harness the power of complex tools, genetic algorithms, hardcore mass-based optimization techniques. And yes, some might call this AI. But this isn't just AI magic. It's about engineering ingenuity. It's pure and simple. It's about understanding the fundamentals like those in metrology to create efficient and powerful solutions. And it is not just for the experts among us. This is knowledge. Knowledge that can be mastered by anyone who is taking the necessary time to understand it. And now I would like to address the up-and-coming engineers, the juniors among us. Sometimes it feels like the mathematics, the science, the coding concepts are out of reach, reserved for those who have more gray in their hair. But this is not the case. To understanding the things we have discussed today, the mathematics, the science, the black belt coding technologies, isn't just about coding proofs. It's about curiosity, research, and a little bit of ingenuity. And let us remember, every complex problem has a solution that can be broken down to smaller and simpler tasks if we take the necessary time to understand it. As we push our limits, what is possible in our fields, please keep that in mind, that sometimes the key to innovation is not in discovering something new, But sometimes it's in understanding something old, something fundamental, and see it in a new light. So let's not just work harder, but work smarter, using every tool at our disposal, starting from the age-old science of metrology to the cutting-edge algorithms, what we are doing at Transcend. Thank you. Thank you for your attention.
Very much. Thank you very much. You still have chances to send your questions using this QR code, either from here or from the comfort of your home or wherever you're watching. And in the meantime, I must say I love the Fallout theme of the slides.
It was that guy again.
I already know.
It was
Very
that guy
impressive.
again.
Very impressive. Congratulations.
Huge kudos to him. It was a big help to me.
Yeah, but you did it a good symbiosis with your presentation, so you were necessary for that as well. And we got our questions.
Jesus.
Yeah, we already have 4. You still have time, so you guys still can have more questions even, so if you have them, ask them away. Number 1. As a software developer, the engineering domain looks terrifying. How do you guys help the developers in understanding and coding these kinds of solutions?
All right. Actually, it's probably I would say that this is the biggest difficulty what we have at Transcend. So it's a interesting question and a good question. But the most important thing when it comes to Transcend is the fact that what we are doing is, yes, I think you can find out it's complicated because currently we are trying to combine and connect completely different engineering disciplines with software development. So yes, it's very difficult to understand. But we have a very good group of people. We have a lot of onboarding materials. We have our own academy, and we are trying to show and trying to share the knowledge across and between our colleagues. But yeah, the question is very well formed. It's not that easy to understand what the heck is happening at Transcend, but we have the necessary group of people to support each other. And obviously, it is not our requirement. It's not requirement from us to understand every specific kind of domain and engineering knowledge from one day to another. Most of the times I used to say that in Hungary we have a 3-quarter trial period, which is a really good one for most of the companies. But at Transcend, after 3 months, the only thing what we can identify is the fact that is the people proactive enough to learn and motivated enough to learn to learn the basics what are needed here or not. We will give them the necessary support to learn a lot, but it's on them, to be honest.
All right, still another one came in the meantime, if I'm not mistaken. I would be interested to see MU units in action. Is there a way to look at it, or is it a private tool that is invisible to others?
Yes, currently we are working in a solution to be able to open up measurement units to the public as well. As I mentioned, we have the sizing.tools website, which was already created. It's public. You can try it out if you are interested in blower or pump sizings, but our plan is to be able to release it as soon as possible to the public. So yes, there will be.
Okay, thank you. I don't have mechanical engineering experience. Would I be a candidate to you if I wanted to take the challenge? I could ask this question because I'm totally not a mechanical engineering person.
Good question. The short answer is yes. The long answer is not that simple. I think everyone has the necessary and the good opportunity to jump into the thing what we are doing at Transcend, but the most important thing is actually the proactivity. If the people who wants to join to Transcend has the necessary motivation to learn and they are proactive enough, then definitely we are a really good company for them. But what we are doing is complicated. We are not a company where someone just can join and just live with it. we need the motivation, we need the proactivity. We will give every kind of support what is needed, but there must be the proactivity and the motivation to learn these discipline knowledge.
All right, thank you. Potentially the last question. We'll see about that. What is the biggest difficulty in working in the critical infrastructure area?
Okay. Actually, yeah, I can separate this question to two parts. The first one was almost covered by me. It's very difficult to work in this area or in this industry when we are just mixing and trying to connect completely different engineering domains. I know there are a lot of companies who are doing almost the same, but just in a specific or specialized area. What we are doing is very new for everyone, and I would say that the answer for my question, the real answer is the fact that it's very difficult to change the industry. So no one else is doing that on the wastewater automation and substation automation. There are no others. Obviously, this can be a positive and a negative thing, because positive one, we are in the first in the line, but it can be very difficult because there is no option to cheat. You cannot see what others are doing, because we are the ones who are actually changing this whole industry. We are automating this generation process. No one else is doing that, and it's very difficult from an infrastructure point of view, and industry point of view, because I would say that the industry, what we are working in it, is not really prepared for the changes, what actually we can do. We had a lot of customer meetings and calls when we highlighted the facts, and we can show them that what we are capable to do and what is already included in the system, and they were like, yeah, it's not happening somewhere in the future, 50 years from now, definitely it will work. No, it's working. So we have to change their mindset when we are talking about the customer base, but also it's a very big leap for us as well, because we are working with a lot of engineers, and actually in the past, all of our engineers did the work by hand with papers, writing down everything. So it's kind of a shift and change in the complete mentality when it comes to the industry level and when it comes to Transcend as well.
All right, thank you very much.